Hello everyone. Today we will learn something interesting. I came across this dynamic kind of repeating geometry technique from Adam Swaab. I thought it was an interesting approach, and I explored a bit on how this can be like done in Houdini. And here I will share my way of doing something like this. Most of these techniques come down to interesting but small scale movement or movement in a pattern, and then repeating them again and again to with different scales and rotation to achieve the overall look. So this is the style we will see how to make today. Let's start by creating a box, and we don't need the geometry, so we'll keep only the points, and we have 8 points. But based on what we want to do, we need to remove 2 points. Instead, what we will do, we'll put them in a group. We'll choose points from opposite sides. You can choose any two number of points. They are going to eventually shuffle, and you're not going to notice anything weird. I'm just choosing 2 points from opposite side and going to put them in a group. This group, we'll call it special. So these 2 points are the special points, and we are going to remove this later. So we'll copy 2 points, some cubes, some boxes, a bit small, just for good visualization. We'll blast out the special points. So these are the cubes we are going to use. But before blasting out the point, we'll do some calculations here when we have like 8 points. But the special points are in a group called special. We'll put down a solver. Actually, before that, the logic, we'll talk about the logic that we are going to use. So for each of our points, the special points, we are going to find 3 neighbors. For example, for 2, number 3 is a neighbor, number 7 is a neighbor, and number 0 is a neighbor. Okay, and similarly for the other point, we are going to find 3 nearest point, and from these 3 nearest point, we are going to like narrow down to one point. For example, let's say number 5 for this point. And then what we are going to do is we are going to interchange the position. That point comes here and this point goes there. Similarly for the other point, for every point we'll do the same thing. It will randomly choose one of its neighbors. Number 7, for example, then this point will go there and number 7 point will come here. And again we will run this for the next loop. So to do this, we need to use a solver because we are going to like deal with position change over time. We have to store a lot of data, and we have to like we need access to previous frame data also. So what we are going to do is let's use the solver and attribute triangle. But first we need to connect the solver to the group. First we will access the special points. Make sure you are running it in detail. We don't want to run it again and again for every point, just once. We will extract the special points and we'll put them in an array called special. Int special is equal to, we can use expand point group. There is one function, yeah, and 0 input, and the name of the group, here it is special. we'll assign it to a attribute just to check. Special is equal to special. Yeah, so the point 2 and 4 are in the group, but we are going to execute all the code only every 50 seconds, sorry, 50 frames. If you see the thing we are going for, it is animating over time. So the animation is triggered every certain frame. In our case, it will be 50 frames. Okay, we'll use if statement. If at frame modulus 50 equals 0. It should be capital F for frame, and we will do all our logic inside the if statement. So only every 50th frame we'll execute this. So we got the special points. In our case, it is 2 and 4. So for each of these point, we are going to do something. So we have to use for each. Using for each, we can access every value of the array and do something with it. Here we need to declare a variable. I will explain why. We will call it I, and the array name, it is special. Now this I will have each and every value of the special, this array. So we are going to get 2 and 4, and we can use this variable anywhere inside our code, and we'll get the point number of the special points. Okay, we will extract the position of these 2 points. Vector, we'll call it pos is equal to 0.0. We need the position, and the point number is I. So it will be 2 or 2 and 4, and we are storing the position. And the next thing is, for these 2 points, for 2 and 4, we will calculate the neighbors. We'll find out the neighbors and we'll store them in an attribute called near PTS. Okay, int near PTS is equal to near, actually this should be an array, int space near PTS is equal to near points open bracket 0 v at p. So near points, it needs at least 3 input. The third input will be the distance. So here, right, we are using 1 meter cube. So you can give anything more than 1. I am going to give 5. And the fourth input, it will be the number of points to find. In our case, we'll find actually 4. You'll see why. Because we need only the 3 neighbors, but we are going to find like 4 neighbors. Because, so if you put this near PTS into an attribute and check, and let's go to the detail, and we will go to frame 50. So it is going to run only every 50th frame. So here you see special point 2 and 4. So these values you see are the neighbors of the value 4. So we are seeing only the last value here. So 0, 1, 2 and 3 is the neighbor it is saying. Let's check if it is true. So 4 it is here, but the neighbors are wrong. Like 5, 1, 6 and I think 5, 1, 6 should be the neighbors actually. This is because if you see we are using v at p here. This is wrong. We can't access the position like this. So we'll use the position that we already stored. Okay. So this is the position for the special points. Now let's see. We have the correct neighbors. But one thing is, if you see the first value, it is the same as the special point. So what is happening is, when we are searching for neighbors of 4, the point 4 is also included in the near points list. Okay. So we are not going to use this. So we'll find nearby 4 points. So from this 4 point, we need to choose 1 point. We'll use random function to choose this, so that we'll get like a random choosing of points. So we can access a particular value from this array. like this. So we'll call it int final pt. So this will be having the point number of the selected point that we are going to select, where the special points will move. Okay, so this is where that empty places in the cube will move. So this point, we have to randomly choose from the near PTS. We can just use the array name like this, and here we can access either 0 or 1 or 2. We'll visualize this. Okay, this is not an array. So we have 4 here. That is because we are accessing the 0th value. And if you put 1, it's going to have the value of 1 from here, and 2. But we need this value to be like random. So we will use rand. But we don't have any variable here, like we cannot use point number because it is running this code per point. So at that time, when it is running for 1 point, there will be only 1 point number. So for all the points, the point number is going to be the same. So we have this variable point number saved already here, I. We can use this, but we'll also use frame just for like more randomization. And we should do it, but there is a problem. This is going to generate a value between 0 and 1, but we need a value between 1, 2 and 3. Okay, so let's do that. We have to do into 2, and we'll make it an integer because we need an integer value here, like 0, 1 and 2. So now we are generating a value between 0 and 2, but we don't know like how many points will be there in this array every time. We are going to remove the sum of these points also. So we'll use this len function, the array name near PTS. So this is going to give the value like dynamically, like procedurally. So now we found out a way to extract the point to which these 2 and 4 points should jump. So now both 2 and 4 have a like a point to jump to. So all we have to do now is like exchange the position. For example, let's say like for 4, 6 is the neighbor. Then 6 position, the position of the point 6, we will assign it to position 4, sorry, point 4. And the position of the 4, we will assign it to point 6. So let's use set point attribute function. We cannot directly set attribute because we are running it in detail. So here the first thing is like let's just interchange the position. First input will be the geometry, and the second will be the attribute name, it is position that we are going to set, and the third will be the point number. So for first, let's take I. So I is the special points number 2 and 4. For 2 and 4, we are going to assign the position of this final PT, but we still don't have the position of final PT. So let's do that first. Vector final POS pos is equal to same point 0. We are going to extract the position. The point number is final PT. So now we are going to use this position here, final position. Okay, and then the last one is the mode. It has to be set. And again, we are going to do the same thing. Trip, same geometry is 0, and we are going to assign position. But the point number is final PT. So for that final position point that we are finding, we have to assign the position of the special point, either 2 or 4. Okay, final PT, and we already have the position POS. So now every 50th frame, these special points should randomly choose one of their neighbor and jump to the position. Okay, let's see what is happening. So here there's an empty space and here there's an empty space. Both of these should be filled. Yeah, it's working properly. Now these two should be filled at 100th frame. Let's reset the simulation. But there is some issue. But before that, we need to animate the boxes. We'll fix the issue later. But to animate the boxes, I found one easy method using chops. Using chops. So normally, like we use this to reduce the jitter in particles or in geometry, and we can use the same filter node actually to smooth out the animation. I'll put a null and I'll call it out, and I'm going to copy this out node, and this chop net should be here and animated. So inside chop.net, put down a geometry node, and now let's paste that out node here, and this should be animated. Now let's put a filter node. Actually, we don't have to do anything here. And now let's reset. If you play, we can see that it is animating. It's too fast. Let's click here and yeah, it's animating. But if you see here, there is some issue. At 100, there is no animation at all. And at 150, there is only one box moving. Actually, we need two of these empty spaces to be filled. Okay, let's see what is happening. We'll visualize the channel. So here, okay, what is happening is the number 2 and 4, they are attracting each other. So this should not happen. So one of these 2 points are like have selected the final point as another special point. So 2 should not select 4 and 4 should not select 2. And if you remember, in our array, we still have these 2 numbers as the 0th value. See? So let's, just after this near points, we will again use for each, and we'll use a different variable int j, and the array values that we need is special. So we are going to take these values and check if they are like in the near points. If they are there, we'll remove it from the near points. Okay, so special remove value. So the array that we want to access is near PTS. I mean, from near PTS, we need to delete the special points. Okay, so this will be the array from where we need to delete the value, and the value itself will be j. So if you remember, the j is like it is carrying each and every value from the special array. Okay, now let's come out. First, let's check here whether we have successfully deleted. Go to frame 50, and we have only 2 values right now. That is because I think before we had like 2 values from the special, and it is now deleted. Okay, so now let's come out. Let's play. Yeah, this works very well. let's increase the frame range and check. Sometimes we need to reset the simulation. So this is what I was looking for. So if you see, sometimes this happens, and when I was trying, this was like happening a lot. Okay, so it, these 2 points go up, and again they come back to the original position. I thought sometimes it happens a lot, and I wanted to avoid this. So we'll write out that final PT as an attribute called last, set point attrib, and 0 will be the input. We'll call the attribute last, and the point number will be I. So the special points will carry this value, and the value will be the final PT. So this is the last time selected point. Okay, and we'll set the value. So if you know about solver, all the data that is going out of this wrangle, it's going to enter the wrangle again, but in the next frame from this previous frame data. Okay, so you can access all the attributes that you are writing here before it. Okay, just that we are going to be accessing it the next frame. So all we have to do this is just remove this final point value from this near PTS. Okay, just after this, remove value, and the first input will be the array name. It is near PTS, and the values that we want to remove is last, I at last. Okay. So we are writing it as an integer attribute. So now this repetition should not happen. I think this is not working. Maybe we are not accessing this attribute properly. Int last is equal to point 0. The attribute name is last, and for the special points. Okay, now we can use this here. Think this should solve the issue. Yeah, right, we cannot properly access the attributes here, like especially point attributes, because we are using detail. So we have to store it as a variable. I think now it should work properly. Let's try. Yeah, you can see like the points, they don't travel back to their previous position at all. So this I found like very interesting. Now we will see how to replicate this properly and create something interesting. So this is my course called Dynamic Pedestrian System. So in this course, we'll create a pedestrian system for an entire block. So the pedestrians will like just move around the city infinitely, but following all the traffic signals. So if you like Houdini in general, or if you want to learn some Houdini crowds, I think this course is like amazing for you. Please consider purchasing it. The link is in the description.